Deborah Shapiro from 321 Contact, and I'm about to do something amazing. I'm about to walk around the world. You don't believe me? Well, watch. You see? That didn't take long. I'm at the South Pole, the very bottom of the Earth.
Three, two, one. Contact is the secret, is the moment. When everything happens, contact is the answer, is the reason that everything happens. Contact. Let's make contact. Three, two, one. Contact.
Antarctica. Getting around. We fly over vast fields of ice, a barren landscape. With Mount Erebus, a still active volcano behind us, we approach our target. Sitting isolated on rough volcanic rock is a small wooden hut. There is little snow here, and the winds are blocked by the surrounding hills. This protected spot is only a quarter mile from the sea, but almost 1,000 miles from the South Pole. 15 men made this place home for a dark winter long ago. What they left behind reminds us of their experience. This isn't a museum, but everything here has been preserved by the cold. The men who lived here had to bring enough food to last over a year. Some of it still lines the shelves. Cans of cocoa, fish, and other foods. The cooking stove was the only source of heat for these men. Christopher Columbus discovered America in 1492. You knew that, right? Well, it wasn't until another 400 years, 1911, that someone made it to the South Pole. It was tough enough for me to get there. It took 30 hours of flying over 4 days. Well, 75 years ago, the trip took months. They had to travel by dog sled or on skis or walk. It took a lot of courage and a sense of determination and adventure to even attempt the trip. This hut was home to a British expedition led by Ernest Shackleton. He came here in 1908 and used it as the starting point for his journey to the South Pole. They left behind this hut and everything around it. Kennels for their dogs, bales of hay for their horses, corn for them too, and food for the expedition, still good after all these years out in nature's freezer. Shackleton and his men never reached the South Pole. Only 97 miles away from their goal, running desperately low on food, they were forced to turn back and struggle 700 miles to the safety of this hut. Later, Shackleton led another expedition. This time, he wanted to be the first to cross the entire continent of Antarctica. Before he could reach land, his ship became trapped in the floating pack ice. His crew struggled to free the boat. They were unsuccessful. After 10 months of drifting in the ice, they had to abandon ship and watch helplessly as the force of the ice crushed their vessel, the Endurance. Shackleton and his men had to turn back. They traveled 500 miles over broken pack ice and another 800 miles in rescue boats on treacherous seas. But throughout their ordeal, not one man was lost. 2 other Antarctic explorers engaged in a race to the South Pole: Roald Amundsen from Norway and Robert Scott from Great Britain. Each chose a different route and wanted to be the first to reach the South Pole. Amundsen was well prepared. He had spent years training with Eskimos in the Arctic. He learned all he could about polar travel. Scott, on the other hand, relied on unproven machinery and animals. His tractors quickly broke down. And although he had brought 23 sled dogs, none of his men knew how to drive them. He was forced to rely on Siberian ponies. Amundsen carefully planned his expedition. He and his men became experts at driving sled dogs and surviving in extreme conditions. On October 19, 1911, the Norwegian explorer and his 4 companions left their base camp for the bottom of the world. Scott left his base camp 2 weeks later, and a month into his trip, found that his horses could not survive difficult travel in the Antarctic. All the horses died. Imagine walking 1,600 miles in sub-freezing temperatures. Imagine camping in howling winds on the ice and snow, trying to keep warm, to keep going. That's what Scott and his 4 companions tried to do. But Amundsen and his men beat Scott to the South Pole. Amundsen arrived on December 14, 1911. After putting up a tent and the Norwegian flag, he and his men left the pole and headed back to their base camp. Still pressing on, the British explorers arrived at the pole less than a month later, only to find the Norwegian flag already flying. Scott and his countrymen were disappointed and exhausted. On their return, with no food left and no strength to continue, they died less than 11 miles from a supply station. 15 years later, the modern era of polar exploration was ushered in by Admiral Richard E. Byrd from the United States. In 1929, he was the first to fly over the South Pole. He tied a small American flag to a rock and dropped it over the pole. He then returned to his base camp. Byrd had with him modern machinery that would allow future polar explorers to be in touch with the rest of the world. The key instrument was the 2-way radio. Until the 1950s, only a handful of people ever set foot on Antarctica. Since then, thousands of scientists have come to study this vast, unknown continent. Antarctica is almost entirely covered by ice. So in order to travel around, you have to use a plane or a helicopter or a land vehicle. And sometimes you have to walk across the ice. But you have to be careful because there are these big cracks in the ice called crevices, which can be hundreds of feet deep. And if you fall into one, you need to know how to climb out. So I'm going to practice with Lynn Bowering from New Zealand climbing out of crevices. But before I can climb out, I've got to climb into one first. Here I go, Lynn.
Okay.
As I descend into the crevasse, Lynn anchors my rope into the snow so I can't fall to the bottom, 70 feet away. Once she's secured the rope, she attaches herself to it and comes to check on me.
How's it going down there?
Great, Lynn.
Hey, I've tied the rope off. You can prosic up now.
Okay. Here we go.
Okay.
For safety, whenever you're walking on the ice, you're connected to another person by a rope. If you fall into a crevasse, your partner can stop your fall, and you can climb out.
How's it going?
Okay. I get it.
It's looking really good.
Ah.
Hey, you gotta make sure you take all your weight off the prosic loop that you're trying to move.
Okay. It's caught in this. The way you climb out of a crevasse is called prosicking. You use 2 small rope loops tied onto the big rope. One small loop is attached to your waist. The other goes around your foot. Prosicking isn't easy. It's a slow process. Up we go.
You've got the system really well worked out there.
Yeah.
Yeah, it's great.
Getting the hang of it. The hang of it, get it?
I get it, I get it.
Okay. You slide the foot loop up the rope and stand in it. Then you slide the waist loop up the rope and sit. Then it's back to sliding the foot loop. It's a process of sitting and standing and using your legs to push yourself up the crevasse. Trying to get it up higher.
If you can loosen the knot off with your hand before you move it up, it'll move a lot more easily.
Slide knot.
Make sure the prosic's on your foot too. It's just slid up around your ankle.
Okay. Yeah, it's a trade-off. If I want to push it up high enough, I have to keep re-putting it on. Learning how to get out of a crevasse is part of a survival course that all visitors to Antarctica have to take. Crevasses are dangerous. They're usually hard to see because they're covered by a thin layer of snow and ice. People fall into them. So do tractors and even planes. So what I'm doing isn't a game. It's part of working and surviving in Antarctica.
You can see it's a better idea not to actually fall into crevasses now, eh?
Yeah. Gonna be really careful walking around. It's fun though.
Doing really well.
I'm almost there.
It's a wee bit of a problem on the flatter stuff. The prosic loop falls off your boot a wee bit.
Okay. There we go.
That looks pretty good.
Uh-oh. Uh-oh. I'm in the rope here.
That'll be okay.
It'll be okay?
Yep, that'll be fine. You're standing on the prosic, not on the rope. Good. Okay.
Should I do it again?
Yeah. Do it just once more.
Make it a good one.
Okay, right up to the waist one. Great. Whoa, bit of stretch in the rope.
All right.
Okay. Coming over the edge sometimes is the hardest part.
All right.
So if you can grab onto the end of the ice axe and then just sort of flip your legs up and around.
No problem.
Yay! You did it! Great.
All right. Hi, I'm Deborah Shapiro, and I'm going to show you one way of getting around on the ice in Antarctica. You use one of these. It's called a Sprite, and there are two really interesting things about this vehicle. First, it has tracks on the bottom, like a tank, and second, it doesn't have a steering wheel, but you can still steer. You just use these levers. To go left, you pull the left lever. To go right, pull the right lever. Simple. You ready to go? The levers control brakes. Right turn. When you pull the right lever, the right track slows down and the left track keeps going. The Sprite turns. Left. Tracks are better than tires on ice. They don't slide or skid around as much. Also, with tracks, the weight of the vehicle is spread more evenly over the surface of the ice, so it's safer. The Sprite, one way to get around on the ice.
If it's the North Pole, it's Arctic. If it's the South Pole, Antarctic. Both poles have ice and snow. But a few things you should know. Polar bears and igloos, the Arctic. Seals and walruses, the Arctic. Owls and caribou live in the Arctic too. If you think it's cold in the Arctic, you're in for a surprise. It is cold in the Arctic, but the Antarctic's even colder. Seals and penguins, Antarctic, not much else. Antarctic, some scientists work there, but no one calls it home. If it's the North Pole, it's Arctic. If it's the South Pole, Antarctic. If it's the North Pole, it's Arctic. If it's the South Pole, Antarctic. Where can you find the wingless fly? The Antarctic.
Getting around Antarctica today is a lot easier and faster than it was during the early days of exploration.
Okay, crew ready to roll?
We take off from an ice runway. Our plane is specially equipped with skis.
Gear up. How's it looking? Pretty good. Okay. Okay, she's up. And flaps up.
We're on our way to the South Pole. Our route follows earlier explorers like Shackleton and Scott. We leave McMurdo, fly south over the Ross Ice Shelf, a permanent 300-foot layer of ice covering part of the Ross Sea. Head up the Beardmore Glacier, a wide river of slow-moving ice that feeds the Ross Ice Shelf. Pass over the Transantarctic Mountains to the Polar Plateau, home of the South Pole.
Debbie, what you're seeing here is the end of the Transantarctics on the west side. of the mountains. This is where they end. On this side is the Ross Ice Shelf. It's the flat ice you see down there. On the opposite side is the polar plateau. What we're going to be doing is flying up what is called an altitude.
Commander Rector and I have a lot to talk about as we fly over an impressive landscape. What are we flying over now? Is this ice over water?
No, this is ice that's several hundred feet thick, and it's grounded. It's on the ground. This is called an ice shelf.
Several hundred feet?
In some cases, thousands of feet. For example, let's see. We are at about 800 feet over the ground right now, but our elevation above sea level is about 5,000 feet. As we work our way through the mountains, we'll end up at an elevation of 10,000 feet over sea level, but we'll be the same 500 or 800 feet over the ground.
So the South Pole is really very high.
9,300 feet mean sea level altitude, and that's about 9,000 feet of ice, about 300 feet of land.
That means that most valleys between the mountains are filled with ice, almost all the way up to the mountaintops. And where it's flat, there's still a lot of ice covering the ground. The snow and ice have been collecting here for millions of years. It doesn't melt away.
Now we're getting close enough here to where you can see the size of some of the crevasses. It's not a place you want to put an airplane. You can see, if you look out to the side, you see where it looks like little paths of snow?
Yeah, it looks like ski trails.
Okay, those are crevasses that are bridged over with snow.
That dark ridge in front of us, is that a bunch of crevasses?
Right, that's a crevasse field, and that's the center of the glacier where the ice is moving the fastest. You notice out to the sides it's not moving as fast because you don't see the same kind of crevassing.
I mean, when the middle moves faster than the sides, it causes crevasses?
That's correct. That's correct.
Crevasses are like rapids or white water in a river.
Exactly. That's a good analogy. Where the ice is moving faster, it looks rougher, crevassed, just like it would rapids in a river that was flowing between the same mountains.
How do you define the edges of the glacier?
Okay, a glacier is any place where confined ice is moving.
The mountains are sort of the boundaries of the glaciers?
Yes,
And the glaciers flow between the mountains?
that's correct. That's how the ice from the polar plateau moves down onto the Ross Ice Shelf. It comes through the mountains. We're going to pop across the Beardmore Glacier, which is the largest glacier in the world, if I'm not mistaken. This is the glacier that Robert Scott's party walked up to get from the Ross Ice Shelf to the polar plateau.
And how slow does it move?
This probably moves more than a meter an hour. You can stand out on it and actually hear it move. Hear it crack and pop as it moves.
Once we're over the mountains, we've reached the polar plateau, and we're not far from the South Pole itself. All that you see is ice, and more ice. Then it's there, the runway at the South Pole.
Everybody in the back will be beginning our descent here. Weather down at the South Pole today looks very clear. It's as cold as we briefed you earlier at minus 45. So it's been fun flying you guys, so we'll see you on deck.
It's as cold as they said, 45 degrees below zero. And it's summertime. Hi, I'm Deborah Shapiro reporting to you from the South Pole. I'm standing on 9,200 feet of ice. That's a block of ice almost 2 miles thick. You know, 90% of the Earth's fresh water is all here in Antarctica, but it's all frozen into ice. The research station at the South Pole is a small complex of buildings, some built under the ice. It's run by the United States. Only about 40 people live here during the summer, and fewer than 20 winter over. But the South Pole and the rest of Antarctica are not owned by any country. In fact, 16 countries have signed a treaty keeping Antarctica free from ownership and free for scientific research. John, you know, I never was really sure whether there was actually a pole at the South Pole.
Well, there sure is, and there it is, and U.S. Geological Survey comes around every year and puts a new one in for us.
Why do they have to put a new one every year?
Well, because it moves, or at least from our standpoint it moves, because...
What do you mean, the South Pole is not in the same place all the time?
Well, really it is, but we live on this great big sheet of ice, you see, and the ice is moving like a big glacier.
Oh, so the metal pole that's in the ice moves over the real South Pole.
That's right.
So you got to move it back.
That's right, that's right. They do that once a year. That was done the end of last January.
But scientists don't come to the South Pole to watch the pole move. They come here to work. We're launching a balloon to measure ozone, a gas in the upper atmosphere. A thin layer of ozone protects the Earth from the sun's harmful rays. In some places, like Antarctica, this layer is getting thinner and more harmful rays are getting through.
It's ready now. You got the balloon.
I got
When
it.
I say go, you're gonna let go of the balloon, grab that towel, let it unravel.
Okay.
The balloon will go up, we'll start measuring the ozone.
Okay.
Okay, is everybody ready? You guys ready?
Yeah,
All ready. Okay, on 3. 1, 2, 3.
There she goes! Woo! Information received from balloons helps scientists understand the complex reactions between ozone, sunlight, and man-made chemicals that attack the ozone. How high does the balloon go?
This helium-filled balloon will go up to 25 miles high in the atmosphere.
When exactly is the sampling happening?
The sampling is happening all the time. There's an air pump inside the instrument that is pulling air into the instrument all the time. It is sampling the ozone and is sending that signal back down to the ground. On the ground here, the signal is being received by a tracking dish, and we can estimate the ozone very accurately.
This is just one experiment. Scientists around the world are trying to figure out how serious the ozone problem is and what to do about it. My time is up at the South Pole. For me, it's back to McMurdo. The South Pole is a place of cold beauty, almost a different planet from the one I know, but it's an important part of our world and an important place for science. It's surprising to think that scientists come to harsh and forbidding places to carry on research. Like the old explorers who came here before them, scientists carry on a tradition of discovery, learning new things about the world we live in. They are today's pioneers. "321 Contact" is a production of the Children's Television Workshop.